I am Sonali Pandurang Patil, Assistant Professor from Sperry's College of Engineering, Pandharpur. Today we are going to learn about traffic signals and its design by Webster's method. Traffic signals with the basic requirements. The use of traffic signals for control of conflicting streams of vehicular and pedestrian traffic is extensive in most of towns and the cities. Traffic signals provide an orderly movement of traffic. When traffic geometric layout and control measures are employed, they increase traffic handling capacity of intersection. They reduce frequency of creation, types of accident, especially at right angles type and pedestrian accidents. Under favorable conditions, they can be coordinated to provide continuous movement of traffic at definite speed along a given route. Traffic signals having a basic requirement. Traffic signals are provided on the roads for controlling the traffic, which will give us most of the information to the drivers, to the uh, vehicles drivers on the roads, and for the favorable conditions these signals are giving the drivers the continuous movement of traffic at the definite speed along the given routes. The Indian practice is to have an amber period of 2 seconds as a transition interval between termination of related green movement and exhibition of road indication, or between termination of red indication and commencement of related green movement. Already we have seen there are the different types of the signal with their colors. There is a red color, green color, and the amber color, which shows the green color, that shows the vehicle should move. Second way, the red color means that vehicle should be stopped, and amber means that vehicle should be in the position to go. Likewise, there are the color. As per the color, there is a differentiation between the signals, and based on this, Indian practice have an amber period of 2 seconds, which will changes from green to the green, which is termination of green movement, to the exhibition of red indications, or termination of red indications and commencement of related to the green movement. Like this, there is a for a period of amber is 2 seconds, which is given here by the Indian practice. And in the diagram there is a total cycle is shown here, first and second. The first cycle, the first case is called as clearance amber, and second case is called as a initial amber. Between these two cases, between these two first and second cases, the whatever the middle amber period which is shown here, that will be of a two that will be become a 2 second. And for the phase number first, that will become 2 second, and again from the cycle first completed, and for the second case, second cycle completion, again there will be a period of 2 second. This total phase cycle, that phase cycle of amber color will become as a 4 seconds. Coming towards the types of traffic signals, there are the different types of the signals classified into the following types. Traffic control signals are fixed time signals, manually operated signals, automatic signals, pedestrian signals, and specific traffic signals. Fixed time signals, these signals are said to repeat regularly a cycle of red, amber, and green lights. The timing of each phase and cycle for pedestrian fixed on the road for traffic studies. The main drawback of this system is that the sometimes traffic flow on road may be almost nil and traffic on crossroads may be quite heavy. Yet signal operates with fixed timing. The traffic in heavy stream will have to stop till till the red phase. Means there are some of the disadvantages of this fixed time interval method of signaling. In this method, the main drawback of this system is that some of the times the traffic flow on one road may be almost nil. Still, the traffic on crossroads may be quite heavy, yet signal operates with fixed timing, so that fixed time interval signal is having one of the drawback, that is the fixing of the signals, fixed timing of the signals. Second one is the automatic signal. These are the automatic signals which in which timing of phases and cycles are automatically getting changed to traffic as per the based on the traffic demand. In these types of signals, the detectors and a computer assigns the right way for various traffic movement on basics of demand and predetermined programming. Means in this automatic signaling, it will take the demand of the road users, and based on this it will measure the traffic volume, and based on this it will automatically change the traffics it will automatically change the phase of the signals. Next point is the we will see here the method for this purpose for fixing these times of the automatic signaling. There is a one new method is generated, that is the Webster's method. We'll see here by using this Webster's method we can calculate the green time for every green time for the vehicle on the roads. In this method there is a optimal signal time. There is a method, there are the most important points are here. First one is the optimum signal cycle, second one is the last time for the vehicle, second one is the lost time for the vehicles and approach roads, where is the q is the normal flow on each approach and saturation flow on each approach. Means in this there is the first point is nothing but a optimum signal cycle. Optimum first step is to calculate the optimum signal cycle. C naught is equal to 1.5 L plus 5 upon 1 minus y, where L is the last time of the vehicle, where is the L is equal to twice n plus r, where n is the number of phases and r is the all rate time. During this all rate time that vehicle should be stopped, that is the last time for the vehicles, and n is the number of phases, where y is the ya plus yb. From that ya is equal to q1 upon s1, that is the for the approach road 1. Yb is equal to q2 upon s2, that will be for the approach road second, where q is the normal flow on each approach, that is the normal flow on each road. There if there are the two roads, then that normal flow on road number 1. If q1 is there, that normal flow on road number 1. If qt is there, that will be a normal flow on road number 2. Likewise there will be a distribution. That s is the saturation flow on each road, that saturation flow on each road. If there are the two roads, then we can go for the s1 and s2 for the saturation road 1 and saturation flow road 2. Likewise, and based on this by from all these points we will get an idea about the green time for the road number 1 and road number 2, and based on this we can calculate the total cycle time for the total green cycle time on the road at the intersection point. We'll see here one question which is asked for the examination. We'll see here the average. First one we'll see the questions. The average normal flow of traffic in crossroads A and B during design periods are 400 and 250 PCU per hour. Saturation flow values on these roads are estimated as 1250 and 1000 PCU per hour respectively. All rate time required for pedestrian crossing is 12 seconds. Design two-phase traffic signal by using Webster's method. Means in this problem there is a intersection of two roads is given, and for the design purpose, for the Webster's design purpose, they have given the saturation normal saturation values of the two roads. And second one is that they have given normal flow on q1 and q2 they have given, and saturation flow on road number 1 and 2, s1 and s2 they have given. And based on this we have to calculate the green cycle time. The first, as per the step number 1, we have to go for the first point, that is the to find the optimum signal time. For that purpose the formula is C naught is equal to 1.5 L plus 5 upon 1 minus Y. And for that purpose the required information is Y, that is L, that will be a lost time. That both these values we have to calculate first, and for that purpose we'll go for the YA and YB. YA is the YA is equal to QA upon SA. What is QA? That is the road number A and road number B. QA is the normal flow on road number A, that will be 400, and divided by SA, that is the saturation flow on the road number A, that will be a 1250, already they have given. So from that we will get an YA is equal to 400 by 1250 is equal to 0.32. Based on this we will get an second value, that will be a YB. YB is equal to QB upon SB, where QB is the normal flow on road number B and SB is the saturation flow on road number B. That both the values are given in the problem, that will be a 250 divided by 1000. From that YB will get is equal to 0.25. After that, for the addition of these two we have to calculate the total signal time. So y is equal to ya plus yb. Ya is equal to 0.32 plus yb is equal to 0.25. It will become a 0.57. Remaining is the L value. L is the lost time value. Lost time is equal to twice n plus r, where n is the number of phases, and r is the all rate time. In this problem there is a n value is given, that is the phases are two phases, that will be a 2n plus r. That r is nothing but a all rate time. That all rate time, that will be a all rate they have given here at the last in the question. All rate time required for pedestrian crossing is 12 seconds. That r value is given equal to 12 seconds. Based on this, L is equal to 16 seconds. From this we'll go towards the step number 1. C naught is equal to 1.5 L plus 5 upon 1 minus Y, where 1.5 into L is the lost time. Lost time already we have calculated, that is a 16 second, plus 5 upon 1 minus Y, where Y is the YA plus YB, already we have calculated 0.57. Based on this it will be equal to 67.5. And based on these above results we'll go for the green time for A road and green time for B road and at the intersection, and that will be calculated by YA upon Y into C naught minus L, where YA already we know 0.32 by 0.57 is the Y value, into C naught is the 67.5 minus that will value as a L is a 16. So we'll get as a 29 second for green time for road A. Second one is the green time for B. For that purpose, YB upon Y into brackets C naught minus L. YB is 0.25 divided by total Y is 0.57 into C naught 67.5 minus 16. Again it will be equal to 22.5 second. Based on this, we'll get the green time for A road and green time for B road. All rate time for pedestrian crossing already they have given as a 12 second. And based on this, we'll calculate the total cycle time, and that will be a total cycle time is equal to GA, that will be a green time for A road plus green time for B road plus pedestrian crossing, all rate time for pedestrian crossing, that is the 12 second, and plus that phase, that will be a umber time for the phase number 1 and phase number 2 for completing cycle, that will be equal to 4 second. And based on this, 29 second plus 22.5 second plus pedestrian crossing 12 second plus the phase 1 and phase 2, as per the Indian practice, that for the clearance of first and second phase, the intermediate umber color indicate amber color to the red to the green color and green to the red color, that will be time as a 4 second. And based on this, total signal cycle time, that will be equal to GA plus GB plus 4 plus 12 equal to 67.5 second. In this way, that will be a total signal time for the signal total signal cycle time for changing green to the red and red to the green, as per the given data into the questions, that is the natural as a natural flow on road A and road B, and saturation flow on road A and road B. Thank you. In this way, that Webster's method from the unit number 5 is getting completed over here.